Good afternoon. Thank you for joining us today for SME's Technical Community and Aerodef Manufacturing Satellite Session. Today's webinar, Developing and Managing Connected Assets Through IIoT, you'll hear how capturing data and information will drive actions that keep assets running at optimal utilization. I'm Carl Mitroff, the Aerodef Manufacturing Conference Manager, and thank you for joining us here today. A few housekeeping items I'll want to cover really quick before we get into today's webinar. You'll recognize right away that all microphones have been muted. And if you have questions regarding the functionality of the webinar platform, excuse me, please use the chat feature. If you have technical questions that you want to pose to our guest speakers this afternoon, you can use the Q&A box in the platform as well. We'll be monitoring both. And in the event of any technical glitches that happen and you find it hard to connect, just know that we are recording today's webinar and we will make it available on demand on our Aerodef website. Before we get going, just want to make a quick introduction to today's moderator, Mr. Bill Biggett. Bill is Vice President, Business Development at JR Automation, and his major responsibilities include the management of business and market development activities supporting all aerospace and defense business units. Bill is also an active Aerodef Executive Committee member and conference advisor with a critical voice in the development of the Aerodef conference content. Thank you, Bill, for moderating today's webinar, and I'll give the floor to you.
Okay, well, thank you, Carl, and welcome to everybody that's joined us here today, and thank you for your attendance. Today, our panel is going to be discussing the benefits of the connected technologies used to monitor real-time knowledge, including the health and availability of IoT assets. What we want to accomplish here today is to show you how you might be able to realize somewhere between a 20 and a 60% asset utilization improvement in a typical aerospace environment while mitigating the risk. Next slide, please. And one more, that'd be great. There we go. Today, we want to really talk about, our experts come from several areas of their experience in their professional lives. We have from the OT side, we have someone from the IT side, and we have someone that's greatly involved in the IoT transformation and digital use process. So I just want to get now and introduce our panelists. First, we have Rajiv Chauhan, who is the creator and developer, architect of industrial and digital automation solutions for the last 21 years in both automation and in aerospace industries. He's led development and deployment of several market disruptive end-to-end solutions utilizing the leading edge technologies. So welcome, Rajiv. Then next up is Dave McGlone. He is the vice president responsible for Hitachi Vantara's digital services, aerospace and defense industry practice. Dave advises A&D clients and the executives on business and digital transformation and oversees the design and execution of strategic digital initiatives. Dave has over 30 years of experience in full lifecycle digital solution design, development, and deployment in a wide variety of platforms and tool sets. So welcome, Dave. And finally, Randy Runkles is currently the chief engineer for the aerospace group at JR Automation based in Michigan. Prior to joining JR Automation in July of 2019, Randy spent 33 years in the aerospace industry in Wichita, Kansas. He worked for both Boeing and Spirit AeroSystems during his career. And his latest responsibilities before leaving Spirit was as a senior operations leader for the advanced manufacturing division. So with our three experts and panelists today, I want to turn this over to Randy and get us going on the OT piece of it.
All right, thank you, Bill. Can we go to the next slide? All right, so what I'm trying to give you here today is a view from operations. I spent many years on the floor as an operations leader and had to come up with more ways to be more productive. So with that, I'm going to attempt to answer about 5 different questions. Where have we been with data and why change? What are useful KPIs? What can an operations leader gain from connected machines? And how does connecting machines change your business? And who in your organization will benefit from connecting machines? So I'll start with the first one. Where have we been with data and why change? The majority of us have spent our lives out there with Excel spreadsheets, and we continue to do that. Excel spreadsheets is a good place to start. You end up with transcription errors. It's not in real time. It's very labor intensive for an individual to have to go collect the data. You have limited data that you collect because you just don't have time. You'll pick 1 or 2 different KPIs that you want to collect data on, and you'll go do that. So while that is useful and has been the mainstay of our business for many years, there's far better ways to do that. And by connecting your assets, that's how you're gonna get more useful data. So what are useful KPIs? Useful KPIs obviously depends on the type of equipment in the business. I'm going to talk a little bit about auto fastening. At my last assignment there at Spirit Aerosystems was we had started out back in the 90s with the Excel sheets, collecting 1 KPI, and that was rivet count on machines. And we thought that to be the end-all, be-all of whether we were efficiently using our equipment, whether our operators were doing a good job, whether we were getting out of our asset what we had paid for, and just the overall health. Well, what we found is back then we started collecting data, and our first connections were just to get rivet count. So it took some of the transcription errors out and took some of the labor intensive work of walking around every single machine and collecting that data. So what you're going to find when you start connecting machines is so many other new KPIs, whether it's machine runtime, whether it's setup time, whatever you're doing in different parts of your business, you're going to pick up different KPIs that you're going to start to analyze. So with that, I'll get into the third question. What can an operations leader gain from connected machines? Well, as a manager on the floor, you're going to start learning a lot about the machine performance. You may have 2 or 3, maybe even 4 machines that are the same, and you're going to start seeing differences in each one of those machines. They pretty much have a personality of their own, and you'll be able to start seeing that. You'll be able to see shift-to-shift performances if you're running a multi-shift operation, which becomes very important as well. Your individual operator's performance, you can break it down to that granularity. In fact, you can break it down into hours or minutes if you want, pulling that real-time data. So one of the other things that we were also able to find is we had multiple machine families that could run the same product, that we started comparing the run times from one machine to the other on the exact same product, and found that we had placed a primary work package on one family of machines where it actually ran significantly better, 10 to 20% better on another type of machine. So without having that real-time data and multiple KPIs to analyze, you'd never know that you had that. And then you also majority of the industry wants to look at OEE, and of course the most elusive part of the OEE is the quality. So we started looking at machine utilization. How many hours a day is that spindle turning? And when is it making me money? And we were very, very surprised to find out that we were in the 30 to 40% machine utilization time. I know that you find that hard to believe, but the actual spindle turning was significantly lower, which brings us into how does connecting machines change your business. So one of my assignments was rate readiness. And typically with each rate break, you're going to go capitalize, and if you're getting a 10% rate hike, then you're going to buy 10% more equipment. So by connecting these assets and truly understanding what it is that our equipment is doing today, we were able to save $70 million in capital assets by going from 42 to 57 aircraft a month without buying any more machines. And all we did was figure out what our machines were doing, where our problems were, whether it was pre-machine, post-machine, whether it was maintenance, whether we had operator errors. We had all kinds of data that allowed us to take these rate changes without additional capital. Some of the KPIs that helped us with those decisions was how long did a machine set in setup time? How long did a machine wait for an overhead crane to load and unload it? How many hours a day did a machine set idle because we either didn't have product for it or didn't have an operator for it? You start analyzing that and start making decisions around your business to fill the voids within that data. So that gets into some of the decision makers who will benefit in your organization from connected machines. So obviously operations is going to benefit, and that was where I came from. And you're going to understand the utilization and performance of that equipment. It's going to help you with the scheduling of that equipment and getting the right product at the right time on each one of those pieces of equipment. Your facilities team is going to benefit tremendously from connected equipment as well. They're going to be able to see when a problem's coming. They're going to see deteriorated performance. They're going to see in your schedule when you can build time in for your facilities team to go in and make the preventative maintenance schedules and get that work done without interrupting you. So your industrial engineers, methods engineers, they get this data, and it's truly amazing some of the things that they can analyze that you didn't think there was any value to. But having all these different data tags coming out of there and putting the correspondence together with one another to be able to make all the decisions that you need to make is very beneficial. But with that, I'd like to turn it over to Rajiv Chauhan to kind of give you some insight on how all that gets done. Rajiv?
All right. Thank you, Randy. Next slide, please. One more. There we go. So thank you, Randy. That was really good, real life example of how you can gain some efficiencies within your manufacturing operations. My job is to kind of bridge between IT and OT. So I'm going to try to broaden the context a little bit. So other than just your machines, there's so many assets you have throughout your business processes, throughout your value chain that are embedded. And what are some of the benefits you can gain by connecting those assets, digitizing those assets? The technology does exist. So Randy gave some examples about machine efficiencies. He talks about 30 to 40% gain. So you have people as your assets, you have material as your asset, you have your building as your asset. So if you digitize and bring your buildings in and make them more energy efficient, you have the efficiencies to gain there. Then you have your people. You bring people within that digital ecosystem, you gain several efficiencies there. Supply chain, you have assets within your supply chain. You connect your supply chain, light it up. In my practice, I call it the supply chain control tower. You set those control towers up, and those could be big gains because that's your working capital, 20-30% efficiency improvement within your supply chain that can add up to your bottom line. So to me, assets is broader. To me, assets is people, machines, materials, building. Those are all your assets. So good. Next slide, please. Now, as I said, my job is to connect the physical world to the digital world. I kind of act as a bridge between IT and OT. So I'll kind of give you the hierarchy of how the technology works and how the benefit come into the picture when you start from connecting the physical world at the bottom layer, which is, let's say you start connecting your machines. So you start communicating with your machine controllers, your PLCs, your robots, your physical machines and automation that you have on the floor. Now the basic things you can start doing is you can start now visualizing the data that's coming out of those assets. You can look into the performances, you can look into the health of those assets. Number of benefits that Randy mentioned, you can start basically getting benefits right out of the gate by connecting those type of assets. Now, as you start connecting more and you start bringing the context even bigger, let's say now we start deploying the asset tracking technologies. We start now tracking our material. We start tracking the vehicles that you have in your shop floor. Different technologies to do that. Now you have broadened the context. So now you're putting things, not just looking at the performances of the machines, but you're now looking into the material coming in and feeding those machines and the material that's coming out from those machines going to upstream, downstream processes within your facility. Then you start connecting the people, various different ways how you connect the people within their digital ecosystem. So you're now basically creating this digital thread, and as you go up in the hierarchy to start connecting each one of these assets, you're now improving or you're broadening the intelligence and the information you're gathering. So now you're making better and better decisions. You're impacting your business processes. So as we go up and broaden that perspective, now you are not only looking at the bottom layer. Now you're connecting and connecting your PLM systems, to your MRP systems, to your MES systems. So you're basically impacting your entire value chain. I give you an example. So you start looking into how at the top level you're now have visibility of how your suppliers are performing. And now you can start looking into how that supplier performance is now impacting your production schedules. And if it's impacting production schedules, now you get a better visibility into how it changes the constraints on your shop floor. It can pinpoint to just top supplier performance can now impact into your all the way down bottom layer of your connected devices, your machines. You can now start looking into where you have those constraints and how you can adapt to those constraints. Next slide, please. Okay, so I'll talk about just some experiences a little bit more towards the infrastructure as we connect a lot of these devices and start creating a digital thread and start creating almost a digital twin of your business. Just a few examples of what you might consider. A lot of you guys might already be on your digital journey. So things that I have seen, I have experienced that might be things to look for or things to plan for if it's a greenfield facility or a process that you're getting involved into. The number one I put there is a solid communication network infrastructure. A lot of time, the old legacy system, if it's an existing facility, you have a lot of challenges how you scale it. So when you plan it or when you deploy it, make sure you plan to make it scalable. You select the devices, you select the routers, the gateways, the equipment that you can, you pick the topology that you can scale. as we connect more and more of these devices, you're putting load onto your legacy system if it's existing, or if you're starting from scratch, then plan in a way that it's scalable, because that's important. As these equipment come alive, you want to be able to scale that network. Introduce the technology, bring in the devices that have a lot more edge computing capabilities. Every millisecond, you're going to collect thousands of tags coming off of different processes, different equipment. So you want that extra brain power upfront at the edge. They can start making some decisions, and you're capturing the data that you really need. Plan for 5G devices as the technology grows, as the processes grow, and as more and more processes gets integrated. You might have processes that are basically at different global footprint. You want to have equipment that have 5G capability, so plan for those. Redundancy. There might be areas where you want some safety, you want some redundancy in your network, so plan for those. You will have in much more automated factories, you will have a lot of devices, especially in aerospace, when you get into dense areas of your facility where you have bigger aircraft integration tooling that have 2-3 decks level high and heavy metal structure. If you try to deploy some technology there, you want to plan that you have ultra wideband network in there. You have ability to deploy. You're deploying cobots, you're deploying AMRs. Make sure you have the network infrastructure that can communicate to those equipments. Then I got some examples here about just the asset tracking infrastructure. It is becoming more, in my practice, as we integrate more and more tracking of materials, tracking of vehicles, tracking of your tools, you need a full infrastructure, either RFID or low energy Bluetooth network that infrastructure that you might want to plan. I just put an example there that it took the aircraft industry so many years to get to the point where now they have automated sorting of your bag. When you check in your bag at the airport, the label they put on it have an RFID tag, but it just took them so many years to create that infrastructure that when they check in your bag, they scan the barcode and it associate that to your booking number, and then when it gets into the conveyor, it just automatically sorts. So plan for those infrastructure as the technology grow, and some of you who might be in that stage where you're either starting on this digital journey or you're now becoming part of a greenfield facility. So that's what we tell our clients, our customers, that some of these things you can plan up front and avoid some of the cost and headache you have once the infrastructure is already stand up. So next slide, please. Okay, so real quick, one use case, one example I'll give you guys. This is the one I'm currently working on. So just digitizing all the way from equipment to a manufacturing cell to then digitizing the entire assembly line and then the entire facility. I'll just pick an example here about a manufacturing cell, and I'll just pick a specific cell that have a machine that lays a dielectric material on a piece of metal for a next tire assembly process. So the way it used to be, the basic steps of how you connect your assets is we'll just capture the basic data that will give us some performance and health metrics, and that's how far we'll go. But we have taken it to the next step where we're looking at, with a vision system, when the machine is laying that material, we're looking where the machine had issues and it left a bead of the material, so there's no continuity, and we want the continuity in that bead. So we have a now in-process quality inspection system that's checking that continuity, and then dynamically reprogramming the robot so it's making a quality disposition to go back and fill those areas to make continuity. But we've taken it even further. So now we're capturing a lot more data. We're putting some more technology in there. Now we're actually teaching a ML model to not only look for where it left the gap, but actually try to avoid the gap to begin with by capturing much more data. You're looking at viscosity, temperature, and multiple other data to actually get to the point where we'll be able to eliminate altogether the reprogramming, dynamically reprogramming to relay that material. So just a hierarchy of progression, how you can connect the devices, start from basic, getting performance and health, to all the way get to the point where you have almost automated closed loop processes. So I'll hand it over to David now. He got a lot more IT background, and he'll give his take on it.
Yeah, thanks, Rajiv. So I'm Dave McGlone. I work for Hitachi Vantara, and I'm going to talk a little bit today about how industrial IoT has transformed a piece of Hitachi's business in terms of rail and transportation. Next slide. Yeah, so Hitachi has been in the transportation and rail business for a long time, right? And a few years ago, we sort of began to think about how can we transform not just our business, but the entire industry to be more as a service, meaning that effectively that would change the way we think about our business model from, hey, we used to build trains and sell trains and get paid, you know, when trains break to fix them, to now we're building trains and deploying trains and managing train systems, transportation systems. And frankly, we only get paid when the train is up instead of when it breaks. And so that was a business model that we changed to. And how does IoT play into that, right? So if you think about that business model change, it's really a cultural change that drives a significant transformation in digital and the way we think about technology, right? So all of a sudden, we're responsible for things like the train running. We're responsible for rider satisfaction, right? And those are the SLAs and the metrics on which we get paid, right? So, you know, metrics like downtime, repair costs, maintenance costs, and rider satisfaction became key performance indicators for the business, right? So when we started thinking about that, we were like, well, we need to be able to monitor that train much more effectively than we did, because we weren't responsible for it. And we need to begin to do things like predicting when it might break so that we can keep it from breaking before it does. So predictive maintenance became important, right? Reducing unplanned downtime became important. As you can imagine, a bullet train going 250 miles an hour has a lot of sensors, 3,500 sensors. Those sensors are sampled at 200 milliseconds. We have a ton of data streaming off these trains all the time. And we've got to be analyzing that data, looking for correlations about, hey, when this happens, or when this happened in the past historically, how do we now begin to look for that situation and when it might occur in the future so we can prevent it, right, rather than reacting to it. So we wanted to move from being reactive to being proactive because that business model change drove that. So this IoT solution that we implemented allowed us to do that. We've improved our customer satisfaction, rider satisfaction on that train from 60% to 80%. We've cut $20 million a year in maintenance savings out. And it's made a huge difference in our business just by sort of deploying this IoT solution, okay? Next slide. So talk a little bit about, the solution. So we think about this from a business standpoint or a functional architecture. We have sensors, obviously, on trains. They're moving. We've got to have all that architecture that Rajiv just talked about to be able to capture that data and ingest it and then store it and do condition monitoring on it so that real time we understand what's going on the train. Is a door stuck, for example? Because a door being stuck is going to decrease your rider satisfaction dramatically. They can't get off at their stop. So there's things like that that we began to monitor for, condition-based monitoring, diagnostics, prognostics. We started moving towards things like predicting remaining useful life of the train or parts on the train, so that we can then get those things replaced prior to them breaking or going out of remaining useful life. And of course, doing predictive maintenance and just a maintenance plan, optimizing our sort of regular maintenance plans is part of what cut that cost on maintenance significantly. And then, of course, we built a single pane of glass to present all that to various roles in the train management organization. So just kind of engineering and and customer satisfaction and other organizations that we presented all that data to. Next slide. So moving from that functional architecture down into now the guts of the IT piece of it, as but I'm a little more focused on IT. What we try to do is look for what I call the pattern in the problem, right? So every product or every manufacturing shop floor has certain commonality, things that need to be done in an IoT solution. And of course, there's a lot of specific things too, right? But what we try to do is to say, what is common across all those things? Well, you've certainly got data sources. Those could be machines, as Randy and Rajiv talked about. Those could be trains, right? But you've got sources of data, and those are going to come in all different kinds of formats, right? Generally, you want to do some processing at the edge of a product, like at the machine level or on the product as it's running. So you need to notify the train engineer that something's gone dramatically wrong. That's a pretty good example of edge analytics needs to happen. So you've got to manage the devices out there on the piece of equipment. And then once the data comes in, you've got to move it, you've got to ingest it and store it, maybe in the cloud, maybe on premise, and do analytics on it, do governance around that data. So understanding like where did that data come from, who owns it, when did it come in? It's all got to be tagged so that it can be useful to folks. So data governance is kind of a key aspect of that's involved in pretty much any solution. And then, of course, on the presentation layer, you've got to be able to draw insight from that data, right? So you've got to be able to build data science algorithms or just even dashboards, right? Insights into what's happening either on the shop floor or on the product, in our case, in the train, right? And so we built some common dashboarding capability and analytics capability that we see sort of across various business challenges. So that's called Lumada, and that's the pattern in the problem. That's the software that we use to solve this problem on the train. Okay. Next slide, please. And then to bring it back to the manufacturing operations, right? That same architecture, as I talked about, same Lumada architecture, pieces of it can be used, of course, to connect machines on the shop floor, as Randy and Rajiv talked about, right? So when we're building the train carriages in those manufacturing operations, we've built solutions that connect those machines using Lumada to give us a single pane of glass across 3 different factories on things like reducing scrap, optimizing milling performance. So just another kind of example of where you think about train as a service. We start at the shop floor, right? Doing IoT solutions there. We've also brought it to the product, the end product, so that we can transform our business model and frankly transform the industry, right? It's not something that's ever been done in the rail industry before. And IoT solutions were really a core component of how we were able to do that and be effective from a business standpoint. So with that, I'll turn it back over to Bill for Q&A. Thank you.
Yeah, thank you, Randy, Rajiv, Dave. Thank you very much for that interesting points on the OT, the IT, and the IoT piece. I guess the first question that came in, probably Randy, this was directed to you. Is that given your operations background, what you did in order to bring that IoT solution to the production floor, Obviously, there were probably lots of opportunities, especially if it was one of, I don't want to say the first time of your initiatives, it was probably newer to the organization. What would you do different? What were some of the lessons learned, or what stood out in your mind as something, if I had to do this again, what would be different this time around?
That's a pretty loaded question, Bill. There's so many things you could do differently. The number one thing that I'd have done differently is I would have started sooner. When we started to architect all this out and do it, we spent a year and a half to 2 years trying to lay out all the pieces of the puzzle to figure out what it was that we wanted to do, what the avenue that we wanted to do. What I do different is get started with what I've got. Get it going right off the bat, get what information that I can get right now, and then build on that solution, not wait to make it perfect. So that's the biggest thing that I'd have done different is get data flowing. There's simple ways, whether it's just is a machine on or off, that can change the way you do your business. So that would be my advice is don't wait till you've got everything in line. If you can get started to start gathering data, do it immediately.
Well, that's good advice. I think oftentimes people think, well, I'm going to wait until the perfect idea comes to mind or the perfect situation presents itself, and then I'm going to jump in. And it never comes out. I think that's really good advice to get started. Take what you have, look at what results it generates, and then work off of that. So good.
Yeah,
good.
you'll learn a lot starting with it that way.
Right. So you wish you would have started in 5th grade, is what you're telling me.
Don't know about that early, but yes.
Okay, good. So the next question, Rajiv, you talked a little bit about, it's great when you have like greenfield opportunities and you can build everything kind of ground up. What are the biggest challenges? The question is, what are the biggest challenges when you're connecting assets to a brownfield or an existing facility? What are some of those challenges that the people watching this might be interested to hear about?
Yeah, I think I'll mention a couple. The first one is just the basic connectivity, right? And there's a lot of old legacy controllers, Fanuc Siemens, PLC controllers that doesn't even have any way to communicate with them. But I mean, the machines work, the assets work, and they produce value. They're in the production environment. But so that's the first challenge. How do you open the communication with those equipment? And then even if you open the communication, then what do you do with those tags? Because there's no blueprint. You go talk to the manufacturers of these equipment and controllers. I mean, they don't have any blueprint that can decode those tags. So that's a challenge to then take those tags and kind of convert them into usable format. Then the other thing that I talked about more specific to aerospace is you have legacy networks or you have parts of your system that are just too dense. Like I talked about major assembly areas in aerospace, you have major sections of the aircraft that require bigger toolings around them when you assemble them. It's just how do you get the network coverage to deploy any kind of technology there? I talked about the AMRs. We were trying to deploy some AMRs on a middle deck of a major section assembly area to manage some of the materials and tooling to basically have full traceability of the tooling. And it was challenging to get the communication seamlessly in those areas. So those are some of the bigger challenges when you start connecting and deploying technology in factories.
Good. No, thank you. I think, David, this one is probably for you. Wanting to know, obviously the train example is really good. What you've given us the insight to is that basically you've taken the train and you've akin it to being a piece of equipment and knowing everything you have can and must know about that piece of equipment, how to keep it running, when to predict it's going to need some work and things like that. This question is more around, do you have an example where there was like a sustainment or a similar situation where you've been involved in the past related to maybe the aerospace world? Anything that was maybe aircraft related, space related, defense related?
Yeah, thanks, Bill. Good question. We are doing some work with a jet engine, a commercial engine manufacturer right now. And on those commercial engines, there's about 1,500 sensors. And the work we're doing is about ingesting that data, storing it in the cloud in AWS, and then building applications on top of that to do things like predictive maintenance, remaining useful life, fairly similar to the train example. There's been a couple challenges with that. One is, of course, you got to deal with the aircraft, getting the data from the engine to the aircraft. Aircraft, of course, airlines tend to control that data, and then we got to get it off to do all that. We've been able to overcome that, but yeah, that's a pretty good, I think, anyway, example of a similar kind of thing, but only, in aerospace, right? So we're moving towards doing that with full flight data. Right now, we tend to get what's called snapshot data when the flight lands, and so the next hurdle, the next challenge is doing that, for full flight data, which of course creates different challenges around the volumes of data and how to manage that, archive, push that data off to remote storage, that kind of stuff when it's not needed anymore. So those are the things that we're working through with that customer right now.
That's impressive, David. I did not know there were 1,500 sensors there, but I guess being a person that spends a lot of time up in the air, I'm pretty pleased to hear that they're monitoring that many things, because obviously failure is not an option there. So good. No, so what you're really doing then is taking all that information when it comes in, and you're looking at it from more or less a predictive maintenance MRO type activity. Is that do I understand that correctly?
Yeah, the idea is, if this customer of ours can get that data in the right format, governed, they can build algorithms, data science algorithms on it that will allow them to essentially improve their on-wing time, right? So, the industry is transforming to be more as a service. And so, just like us in the train, these manufacturers, these engine manufacturers are getting paid more and more only when the engine's running. And so, the idea is to begin to do predictive maintenance, to optimize our condition-based maintenance, do fleet management off that data, flow that back into sustainment systems or MRO systems so that we automatically generate, tickets for maintenance activities, field service to occur. There's sort of this closed loop of, pick the data off the engine, analyze it, determine what might go wrong. If there's investigation that's needed, then flow that through to the field, right? For sustainment activity. So, yep, you got it.
Well, I think that's a good segue into the next question here. What I find really interesting is the business model that we're being paid to keep equipment up and running versus only paying for PM type maintenance, which is more or less PM is great in that it tries to predict over a period of time what's happening and when you should do something like change your oil in your car or something like that. But now we're saying when the machine is up and running, there's like a payment program. When it's down, then we're not getting paid. So a very interesting business model. I appreciate that. But the question that kind of leads into here is, Randy, I think it's back to you. Thinking about it from an operations aspect, what's changed your expectations or your buying habits, or when you're looking at new equipment? How does this type of maybe predictability or analytics, how does that enter into your decision when purchasing equipment?
Boy, it's really made a big difference in purchasing equipment. I had some of that responsibility as well. And in aerospace, there's so many pieces of equipment that are 20, 30, 40 years old sitting on the floor. And then when you're trying to capitalize moving into higher rates or different products, you're getting new equipment coming in. And Rajiv kind of touched on it earlier about all the data tags that come out of some of these legacy PLCs and even the new PLCs. If you don't have that blueprint to be able to know what these tags are coming out of there, you have to do the data mining yourself and trial and error and figure out what's coming out of a Siemens or a Fanuc to try to get usable data. So what my expectations have come to is an IoT capable piece of equipment right out of the box. When I order a piece, I want to be able to plug an Ethernet cable into it, know what all the tags are, have them all identified, and data to be flowing so that I don't have to do all of that. Your car tells you, has all that information to you. I would expect these big machine tools to do the same and that be a standard offering within the equipment that is produced today.
Good, Randy. Thank you. That's a good insight. Rajiv, one more question came in when you were talking regarding the connectivity and the data tags that Randy's been talking about. Direct wired, wireless, are those the only ways to connect some assets? What other ways, would our customers be thinking about, or the clients be thinking about, for connecting some of their assets?
The good question. I think this is a good continuity of the challenge and the solution. And the solution is, the answer is yes. There is just the wired connection or wireless is not the only way to connect it. There is other ways to extract the information. I mean, the way in the last 5 years the technology has advanced. I mean, there's ways to get some usable data. I'll give you an example. There is computer vision systems that run based on an AI algorithm that you can teach it to look at a asset that basically you cannot find any way to communicate other than just looking at the HMI screen or the control panel. And you can have these computer vision systems, and it's not very expensive. You can have them constantly looking at those HMI screens, and you can teach it to capture certain values. You can constantly keep looking at, for example, the spindle RPM. So every time that number changes, the computer vision system just captures it within milliseconds. So that's a way to have that live data coming in without even communicating to that directly to that controller. Then I'll take it in a different example as well. I talk about, to me, assets is people as well, right? How do you bring people into that digital ecosystem and collect that intelligence so you're making those decisions? I'm again going to go back to my experience in my context of aerospace workers, right? Aerospace mechanics working in ergonomically challenged positions in different assembly areas. Their technology exists. We're using TOF sensors. We're using LiDAR sensors to look at hand-body motions. We're collecting data. I mean, we're collecting all that intelligence, and we're using that intelligence to make decisions about where safety issues happen, where injuries happen. So all of that is also digitizing and communicating and bringing that information and making decisions. So different ways to digitize and create this digital thread and communicate to different assets.
Great, Rajiv. So another question, Randy, any examples that you could give to show that there's what kind of predictive machine analytics that one could expect, say, an example on your floor or a few examples from your floor that you found very beneficial and able to basically help you predict what you talked about earlier, which is hey, this machine's going to need some attention in the next week or something. What were some good examples that you had?
I got one good one, and Randy, you can give,
Oh.
I'm sure, more than one. I'll give one we did, and Randy and me, we worked on that project at the same time. So we, not necessarily the machine health, but the performance related. We were actually collecting the machine tags and the machine data, and we were looking at that CNC program running on those machines. And we found, or we predicted, that certain programs behave differently on different machines, and therefore results in different cycle time for the parts, just by looking at the pattern of how those parts are run on different machines and how some of the parameters are set differently on the machines. So just predicting, again, not necessarily the health of the machine or the failure, but the performance. You can even take the predictive scenario to the actual performance.
No, you're exactly right, Rajiv, and that's, I got into a little bit of that conversation on what KPIs are useful, and that you would be surprised at when you start collecting data what you can do with that data. To answer your question, Bill, there's a number of different things that can go into the predictive health of a piece of equipment that you may not even think of. You've got your standard ones like heat and vibration, speed deviation, those types of things. But you can also start picking up different patterns, trends, and analysis based off of degrading cycle time for just a particular cycle, or cutting times, whatever type of piece of equipment you've got, and start looking at those and saying, why is this different? What has changed? What is fixing to break? What's the most common thing that could contribute to this? Is it my operator even? Why am I now getting fewer cycles per minute or per day? And it's not going to pinpoint exactly where you're at unless you're doing temperature sensor on a spindle, or ATC pressures or something of that nature. But if you have a change within your operation of a piece of equipment, you're going to start picking that up. You won't pick it up if you're still with your Excel workbook, because you're only collecting a couple of different things. And it gets back into, what do we collect? I suggest you collect everything you can, and you're going to find a way to make it useful to you. And your facilities team, your reliability team, is going to be able to use a lot of that information to go figure out why this thing's running slower. Why is it making mistakes? Why is the quality worse? What's changed? And be able to figure that out. So there's tremendous value in collecting that data for your predictive analysis, and getting into your PM schedule, understanding what that machine is scheduled for and doing, seeing whether it's a critical failure that is coming up, or whether it's something that we can put off to the weekend, is tremendous value.
Good, Randy, thank you. I mean, I think that's a really good point, that trend analysis, watching over either a short, discrete period of time or over a much longer time, and being able to determine that the health of the machine might be needing some attention or in jeopardy. So, great points. We got about 2 more minutes. I'm going to ask Dave one more question for you. Came in when it comes to having data that's being passed around the internet, and maybe cloud-based, it may be this, it may be that. What kind of concerns have been expressed to you when it comes to like data security, or are there any regarding this type of information?
No, that's a good question. Yeah, absolutely, Bill. Data security is a key component of any solution. We've got to, frankly, comply with things as simple as ITAR and EAR, export compliance, regulations around technical data. Typically, what happens is that drives us to either a government cloud offering, a gov cloud offering from Microsoft Azure as an example for storage, which helps with that compliance and data security, or on AWS, same thing. There's an AWS Gov Cloud offering. Google's cloud doesn't have one. So that's just an example of the considerations around data security. But yeah, it's critical. And as you can see in the news, right, companies are finding out that their stuff is not as secure on premise as it might even be in the cloud. So frankly, we see a huge move that direction. And, in this industry, what that really means is government cloud. And in the government cloud, there's less functionality, less capability than in the commercial cloud environments because those vendors have to go through certification. That takes 6 to 9 months, depending on the service that you're talking about using. So, but that's what we see, and that's one of the ways that we've been working through addressing data security concerns. Yeah, good question.
Good, Dave. Well, thanks for for helping maybe put at ease some people, maybe make some more nervous. Gentlemen, we're really at the end of coming to the end of our hour here, and I really want to thank all three of you, Dave, Rajiv, and Randy, and appreciate your insight, your experience, what you've been able to share with us today, and really look forward to. I'm sure the people that attended the seminar and those that will watch it in the future have learned something today, and I'm sure will be very grateful when they look to their own IoT solution in implementation of it. So with that, again, I'll pass it back over to Carl.
Thank you, Bill, and thank you, everyone. What a great discussion this afternoon, very informative. Special thanks, of course, Bill, to you for helping put together today's webinar and moderate. Really appreciate it. And for all of our guest speakers for taking time out of your calendars to join us and to provide your technical insights. Also, of course, we thank all of our attendees who participated, and we hope you found this to be valuable in the conversation, insightful for you, and look forward to seeing you on future webinars. As I mentioned earlier, today's webinar has been recorded or will be recorded and up on our AeroDef webpage momentarily, so please allow 1 to 2 hours for that to happen. And a quick promotion for next July's promotion, July 22nd, 3 o'clock to 4 o'clock Eastern Time. The next satellite session is Multifunctional and Smart Aerospace Coatings. Registration for that webinar is now open. And thank you, everyone. Again, I appreciate the time and enjoy the rest of your day. Thank you.
Thank you, Gar.
You're welcome. Thank you.